Hello, this is Sakib, and in this video we will take a look at the partial dependency plot node in Knime. This node was recently introduced in Knime to improve the interpretability of machine learning models. So a partial dependency plot shows you how a model behaves when the values of a continuous predictor changes within a predefined domain. This is a really great tool to understand how your model will behave with new data. And as a data scientist, you should, in addition to having a good accurate model, you should also be able to explain how your model is working. So this is the right tool for that. So let's take a look at the output of the model. So let's take the interactive view, and this will launch a Chrome browser. It takes a little bit of time because it's rendering I think it's rendering a SVG, and once you have that, you'll see all the plots. And there you go. So we have our first plot, and let's just take a look at the two axes. The bottom axis is your continuous predictor, and the y-axis is your class probabilities. In our case, since we are analyzing a phone subscriber data set, and we want to predict if it's going to be a churn or not, so we have the class probabilities for churn equals to true. Now, looking at this plot, we can one thing really stands out, that as the number of day minutes, so that's the number of day minutes that the subscriber is consuming per day, or over the billing period, increases. The behavior of the model is that the class probabilities for churn equals to true goes up. So for example, if the subscriber has 320 minutes, the class probability is 0.6. So now, based on how you have defined the cutoff, this could possibly be a churn equals to true. So that's looking at how the day minutes show up in the partial dependency plot. Similarly, you can look at the other continuous variables. So we just keep the data short, and so we take a look at evening minutes. Let's take a look at that and see if there's a trend in there as well. So evening minutes, we don't see much of a trend. It does go up. Maybe these are just people who talk a lot, and whether it's daytime or evening time, but maybe the daytime is more important for this, or at least in this model, because the daytimes may not be free versus evening minutes are free, something like that. So good thing to it would be good to explore that. And similarly, if we want to take a look at our account length, that's the number of days the subscriber has been active. So if we look at this, we see that it's a pretty much a flat line. There's a slight bulge over here, but it's a flat line, indicating that the account length does not really, at least the model does not, this particular model does not behave any differently when the account lengths change, if you use different values for that. So the class probabilities remain pretty much the same, around maybe I would say 0.03, and so that's not, there's not much change over here. So it's really, these plots really help you understand how your continuous predictors are contributing to how your model is behaving. So it's really you need to understand that, and these plots are key to that. So now let's take, so that was the output from one of the models, one of the neural network models. So let's take a look at the output from another neural network model. And for some reason, okay, so there you go. Again, we will launch the interactive viewer, which will launch a Chrome browser, And let's see if we have the same trends as we saw in the other model. And so here we have the day minutes. Again, we see an upward trend, which plateaus off. But I think overall you see the same pattern, that as the number of minutes increase, the class probability of churn equals to true goes up. It doesn't go up the way that the other one went, but there is definitely a trend. So I think this is something worthwhile exploring. So similarly, let's see if the account length has any bearing on how the model behaves. It does, and you can see in this model the account length, the more you have stayed with the phone company, the class probability of churn equals to true goes down. So if you have stayed there for a long time, you might just stay there for additional time. So really good plots to explore. Again, you want to get an understanding of how your model is behaving with different data. These are the plots which help you do that. So now let's take a look at how to get to these plots. It's really straightforward. It's really simple. The way that this works is you have your models, your training data set, and your testing data set, and you're building your models in this over here, and then you are you're using the predictor nodes to predict the values. So to use the partial dependency plot, or to build out a partial dependency plot, you use the partial dependency plot node, and in addition to that, you have to use the partial dependency pre-processing node. This node is available on Knime Hub, so you can download that and use that as it is in your workflow. It's a meta node, and so basically what you're doing is that instead of sending your testing data directly to the predictor, you're actually passing it through the partial dependency pre-processing node, which creates a sample for your predictor. And if you take a look at the configuration for the partial dependency pre-processing node, you'll notice that these are all the continuous variables that you want to include in your or at least you want to plot for your partial dependency plots. You'll notice that I did not include longitude and latitude, which doesn't make sense to plot those in this case at least. So and we have all the other continuous variables in this pre-processing node. One thing to note is that all of these have to be for this node, they have to be double. It will not take integer or long or floating points. It has to be double. So just make sure that all your continuous variables are double, and then once you have that set up, you need to pass that into the predictor node, and output of the predictor node goes into the partial dependency plot node. And let's take a look at the configuration for the partial dependency plot node. Again, we want to, in this node, we want to include, or the configuration for this node, we want to include all the continuous variables that we want to plot. And then right here at the very bottom, we have this is your class probability. In our case, we want to see if it is churn or not, so we set it to probability of churn equals to true. And again, this is the probabilities are coming from your predictor node. And so once you have that, and if you don't see the probabilities of your the class probabilities, you probably don't have the class probability check marked in your predictor nodes. And to do that, you just go into your configuration, and then you can append columns with the normalized class distributions. Similarly, over here, we want to make sure that the class properties are included right here. So that looks good. Now, once you have that and you have configured your partial dependency plot node, you can just run it, and it will get you the output. So this is a really good tool to explore how your model will behave with new data, and also shows you how changing a value of a continuous predictor changes the behavior of the models, and what's the prediction essentially of your model. So hopefully you will take a look at this node, and you'll find it useful. And if you have any comments, just leave them in this video. Thank you. Bye bye.